5-8 rational zero theorem. Goal 1 is to identify the rational zeros of a polynomial. What that basically means is any of the zeros that are integers or fractions, anything that's rational number. The rational zero theorem is basically, I just kind of wrote this in my own words, the zeros of p of x that are in the form of p over q, so a rational number. P, the top number, is a factor, or all the p's are factors of the constant of the polynomial. The q are all the factors of the leading coefficient. Okay, so whatever your polynomial is, the constant, the last number, are the factors of p, and the last number, or the first number, the leading coefficient, are the factors of q. So let me show you how that works. Okay, so we have here p of x equals 3x to the fourth plus 2x cubed minus x squared plus 9x minus 12. Nothing matters in this right now when you're finding the possible rational zeros. Now we're just looking for possible ones. We're not actually looking for the real ones right now, or any of those zeros. We're just looking for what could possibly be a zero of this polynomial. So basically, the top number of any of our zeros that are possible are the factors of negative 12, and q are the factors of 3. So what I want to do is I want to list out all the factors of negative 12. And to do that, anytime you list out the p's, we're going to use plus and minus, because both positive and minus numbers are factors. So in this case, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, because 3 times 4 is 12, plus or minus 6, because 2 times 6 is 12, and then plus or minus 12, because 1 and 12 are factors. Okay, so these I know are all the factors of negative 12. The factors of 3 are just 1 and 3. Now the bottom numbers, q, we do not need to do plus and minus. We only need the positive ones, because we're basically taking all of the positive and negative ones over the positive ones, which are going to give us both positive and negative. Okay, now we list out all the possible rational zeros, p over q. So basically we are taking all of the p's and we are going to put them over 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, or 6, and plus or minus 12. Then we take all of the p's and we put them over 3. But we don't list them if they're already there. So in an example, we take all the 1's over the 3's, so plus or minus 1/3, 2 over 3 plus or minus 2/3. The next one is plus or minus 3 over 3. Well, plus or minus 3 over 3 is 1. That's already here. We do not need to list it. Plus or minus 4 over 3. 6 over 3 is 2. That's already here. 12 over 3 is 4, and that's already here. So these are the possible rational zeros. Now, obviously, they are not all rational zeros, because you cannot have 1, 2, 3, 4, 5, 6, 7, 8, 9, 18 different rational zeros. This is just a smaller list of possible ones when you're looking for rational zeros. Okay, you don't have to look for infinitely many numbers. You just make a smaller list. Anyways, that's the whole idea behind this. So what you have to learn how to do is just basically learn how to make this list. That's not necessarily what we're going to use to solve for the rational zeros or any zeros, but that is part of section 5.8. Okay, the first goal. Okay, so what you might want to do is you might want to try these right now. You can pause the video and try these, and then I will go over them here in a minute so you can check your answer. Okay? So go ahead, pause it. I'll see you back here in a second. Okay, welcome back. So let's go over this. All the p's are all the factors of 10. So 1, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. All the q's are 1 and 3. So basically we're taking all of the top over all of the bottom. So the p's over the q's are plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. You're always going to list these again because that's all over 1. The second one part is to take all of these over 3. And obviously none of those are going to simplify, so you're basically going to have more there, another 8. So plus or minus 1/3, plus or minus 2/3, plus or minus 5/3, and plus or minus 10/3. So this is your answer right here. Okay? On the second one, 1b here, we have all the p's are the factors of 24. All the q's are just 1. So basically, p over q is, in this one particular, since the only denominator is 1, you're basically just listing the factors of 24. So all the p's over q's are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. 6 times 4 is 24. So the next number would be 3 times 8, 2 times 12, and then 1 times 24. And those are all the factors and the possible rational zeros for this problem. That is goal 1. Just making a list of possible rational zeros. That's all you have to do.